Welcome to clickmyproject.com.
Most active band attack and countermeasures in a cognitive radio network. In this paper, we examine a type of DOS attacks and evaluate its impacts considering a multi-band CR cognitive radio network. In this attack, a malicious node CR node or agent senses and monitors the signal activities over each band. For example, spectrum sensing through energy detection, and then the attacks with the intentional interface, the band which has the most signal activities outcome. The band under attack could have either primary or secondary users. We refer this as the most active band, that is MAB. In this paper, we investigate a type of attacks on a cognitive radio network with most active band attack, in which the attacker or a malicious node senses or determines the most active band within a multi-band CR network and targets this band through a denial of service attack, DOS attack. We propose a countermeasure strategy, coordinated concealment strategy, to counter the MAB attack. This is the flow of our project. Consists of 5 modules: network creation, spectrum sensing, most active band attack, and coordinated concealment strategy, and a performance evaluation. In the network creation, we form the primary network and the primary users, secondary network and secondary users, secondary base station and spectrum broker, and other agents in the network creation. For primary users have the license to operate in a certain spectrum bands. Primary base station controls the access of primary users to spectrum. In secondary network, secondary users and secondary base station and secondary brokers are present. Secondary users have no licensed bands assigned to them. Secondary base station, a fixed infrastructure component with cognitive radio capabilities, and provides single hop connection to a secondary users. Spectrum broker, spectrum broker scheduling server shares the spectrum resources between the different cognitive radio networks. The next module is spectrum sensing. Spectrum sensing. Cognitive radio user has the ability to sense the unused spectrum at any time and location. We assume number of primary and secondary nodes are in cognitive radio networks as number NP and NS and operating in a M-band cognitive radio network. In each band, C is specified as the maximum user or node capacity, implying that the maximum number of nodes which can be allocated within a band is C. We assume that feature reduction and based spectrum sensing is implemented in each secondary node so that all secondary nodes avoid bands with primary nodes. The next block is most active band attack. A malicious cognitive radio node or agent senses and monitors the signal activities over each band, for example spectrum sensing through energy detection, and then attacks with the intentional interface the band which has the most signal activities, for example the highest energy level, to achieve its maximum attack outcome. The next block is CCS, to avoid the most active band attack. The objective of CCS is to minimize the number of nodes in the targeted band, which maximizes the number of surviving nodes. To implement CCS, the distances between nodes and the attacker can be estimated based on the signal strength information. A central agency or node can be used to collect the signal strength information and perform optimization in determining sacrificing nodes, and if power control is implemented, required transmit power levels. Our objective is to maximize the number of surviving nodes. The next block is evaluation, performance evaluation. For performance evaluation under MAB attack, we calculate the number of surviving nodes, for example nodes which are not in a targeted band, over the total number of nodes. Our results show that the CCS strategy significantly outperforms CR signal avoidance technique under a MAB attack. Open the source code folder and main.m file. Please wait a moment, the output will be appear. These here I display the distance between the secondary node and malicious node, that is fault node. The number of primary surveying nodes are 26, number of secondary surveying nodes are 25. These are the performance evaluation graphs. Initially the figure 1 shows the network formation, that is this is the malicious node. These are the primary and secondary nodes. secondary nodes. Here I figure 2 shows the arrival percentage of the secondary user versus number of secondary users. This is our existing method, that is CC, signal avoidance method. This is our proposed method. Compared to our existing method, our proposed method increase the number of secondary users outage probability. Figure 3 shows also the number of secondary users versus survival percentage of primary users. Signal avoidance, the red line shows the existing method, and the remaining are CCS with no power control, the disable power control. Compared to existing method, our method performs better. Figure also shows the number of secondary nodes with the secondary user outage probability. This is the signal avoidance existing method. This is our proposed method. Compared to existing method, our proposed method outage probability is less than the existing method. This is the number of secondary nodes versus primary user outage probability. This is our existing method, signal avoidance. This is our proposed method with different power controls. Compared to existing method, our proposed method performs better than the existing methods in the literature. Thank you.